the majority of projects will go over budget and over time. So we're really taking away people's opportunity to make the best use of their money by getting the estimate wrong. You know, our clients and our owners, they don't care about the excuses. What they want to know is, what is this thing going to cost? First of all, machine learning is not a silver bullet, so it doesn't solve every problem. In the end, artificial intelligence really isn't a thing by itself. It's a socio-technical tool.
Welcome to the Cost of Everything podcast. This week, I talk to David Porter, co-founder of the Endeavour program and strong proponent for artificial intelligence in cost and schedule estimating. We talk all about the fundamental purpose of an estimate, where we are currently going wrong, and how AI can help you improve. Subscribe and share the podcast with your friends and colleagues. I post episodes every 2 weeks on a range of topics. Here is my chat with David Porter. Thank you, David, for joining me today. Really interested to hear this particular part of cost estimating and the future of cost and project management in this era of AI and machine learning. So,
thank you very much. It's great to be here.
First question, as always, is what is your background and how did you get into cost and project analysis?
I'm an engineer by trade, civil engineer by trade, and so pretty much my entire professional career has been in project management, and of course that's really revolves a great deal around cost and time management also. So, you know, I started out in the construction industry and doing infrastructure projects and building projects. Later on, I founded a project management firm, which became a pretty sizable firm, and we did everything from ports to hospitals to rolling stock projects to ICT projects, pretty much anything you can think of. So I guess that was really close to my heart. You know, clients are always wanting to know what it's going to cost and how long it's going to take, and very regularly things don't go as planned. I sold my firm in the end of 2015, and because I could, I thought, well, maybe I'll go and see if I can find out, you know, what's world's best practice in this sort of stuff, what makes projects work and not work. As a result of that, I went to University at Oxford there, where I met a number of people and found a new way of doing things. And another chap there was the only other Australian doing that course. And he and I got together, and he developed a concept for AI about how we might use that to control time and cost. It just sort of emerged from there, and since that time, which I guess was the end of 2017, we've been heavily focused on trying to take artificial intelligence and machine learning and apply it to time and cost outcomes on projects. And we've had a fair degree of success at that now. And it's really been a fascinating journey so far.
I can't wait to get into this, because this is when I saw your posts and I've seen things related to AI in cost and project management. We have, there's obviously a lot to unpack there, but I thought it's good to kind of go back a step. The question is, why do we estimate and manage cost in the first place? You know, even from fundamentals, it's a really important point just to cover.
That is a really good question, actually. And, you know, I talk to a lot of people, and a lot of the time we talk about how we can improve cost estimating and so forth like that. But I think it's a really good idea to go back to the beginning and say, well, what's the point? Why should we bother estimating cost at all? Why don't we just do the project? When we get to the end of it, we can add up everything that it costs, and then we'll call that the estimate. It'll be 100% right. So, you know, I mean, I think that's a really important philosophical question. And I guess the answer to that is that we do any estimate, a cost estimate, a time estimate, the estimate of the amount of time it's going to take us to get from, you know, to get on the train from point A to point B. We do all of those estimates because we have an expectation of some benefit that we're going to get from that process. And the benefit that we're trying to get from a cost estimation point of view is we're trying to deliver a project for an estimated cost, that is, the cost that we predict will be the outturn cost, so that we can make a decision about whether we do the project or not, or under what terms we do the project. What that means is that if we get the estimate wrong, that is, if the project turns out to cost something different from what we expected it to cost, then people are disappointed. And that goes for everybody, in the supply chain. So the owners of a project, think that they're going to get a block of units for $20 million. They've got pre-sales on the units and they think they're going to sell the units for $25 million and therefore make $5 million of profit. So if those block of units, cost $24 million instead of $20 million, then they're only making $1 million of profit. And that's not what they expected. Similarly, the contractor, he thinks he's going to build the units for, say, $19 million and he's going to make $1 million of profit on the $20 million. But if it costs him $22 million, well, if he signed a contract on 20, then he's just lost $2 million. So it's really, really important to get the estimate to line up, to get the expectation to line up with the actual outcome. That's really what any estimate is an attempt to do. And the sad reality of the fact is that we're just not very good at that. You look at all the data tells you that the majority of projects will go over budget and over time. The majority. There's an argument about what the majority is. There's people who say it's 60% and there's other people who say it's 90%. And there's a variance around whether it's this industry or that industry. But the fact of the matter is that the majority of going over time and over budget. If we said, well, we're going to get on the train from Oxford to London, and the majority of the time there would be mechanical problems, and every now and then there would be a really serious problem, there would be outrage, and people would demand that the rail system was better and performed more to expectation.
I like the way you picked a train journey in the UK, which is notoriously difficult to predict anyway. But you've got a situation where you've got different people making a decision on when they're going to catch a train. So if you have a train every half hour going into London from Oxford, and you're optimistic because you're like, oh well, normally it's on time, so I'm just going to catch the later one. But you happen to join that journey at a time where either there's a technical difficulty, or let's say the train drivers slept in, so there aren't enough train drivers that day. What we're saying is that decision maker who's very optimistic has basically scuppered his journey, whereas someone else who might be like, well, I've been doing this journey for the last 10-15 years, I know how often these are late, so I'm just going to catch the earlier one, and if it's late, at least I'm still going to get in on time. You've essentially got other decisions that are being made around the estimate itself. So in my experience, it's not always about the number being wrong, it's about its interpretation and maybe how decision makers then decide to bulk up that estimate or trim it down as well. I mean, what's your experience with that? Is that something that you think affects things?
What you're getting into there is the whole notion of decision theory. Like, how do we go about making decisions? And this is a large area of a lot of study, but I'm just going to make it a little bit simple here. The common thinking around that is that we make any decision of any description in order to get some sort of expected utility, some sort of benefit out of the decision that we make. And we constantly weigh that decision against other things that we could deploy those resources to, against other decisions that we could make. So, for example, in the Oxford thing, you might decide, if you might be somebody who wants to take the earlier train, but you have a job interview at the time of the earlier train, and so you say, well, sensibly, I should take the earlier train and allow some more space, but I really don't have time for that at the moment, so I'm going to take my job interview and then catch the later train. Or you might then say, but I know that the train's a problem, so I'm going to take my job interview and then I'm going to drive to London. Why you would ever do that's a mystery, but never mind. So, so people are constantly weighing up the cost and the benefits of decisions. And when we're talking about projects here, we're talking about decisions that ought to be made in the best benefit of the stakeholders of those projects. So, in the case of public projects, they are the taxpayers. In the case of projects that the likes of BHP might make, they're the stakeholders of BHP, which include the shareholders and the like. So we're making decisions on projects that are already subject to another big problem, which is the collective action problem. So how do we make a decision and get everybody to do the same thing in order to get a benefit for the collective? And so it's a very, very complex process. And the cost estimate and the time estimate are two really critical factors, because They are the factors that people use to determine whether we constantly use the term, is the business case effective? So is the feasibility working right? They are two critical, really important factors that determine whether or not we would do this project or some other project. And they're also the factors, that we report to our stakeholders. So we say to the stakeholders, I'm going to build this piece of rail infrastructure upgrade from Oxford to London, and it's going to cost 1.2 billion pounds. And we tell people that, if it costs 2 billion pounds, society may have chosen to do something else if it was going to cost 2 billion pounds. So we're really taking away people's opportunity to make the best use of their money by getting the estimate wrong.
In that situation, you're sort of setting expectations as well. So even if there's no perception from the stakeholder of what expensive or inexpensive is, if you set the expectation that this is how much it's going to cost, and then later on you've got a revised budget, you might have more detail, the project might have changed, scope might have changed or something, or conditions or contractually something has changed, and that's pushed the cost up. There's a perception then that it's an expensive project. It might have gotten more expensive, but in the mind of the stakeholder, that's perceived as expensive and therefore less value, but that might not be the case.
Yeah, that's exactly right. It might have always going to have been that expensive. Getting those estimates wrong can be a career limiting move, as numerous projects in Australia and the UK, e.g., London Crossrail, Sydney Light Rail. There's a whole bunch of projects where you've seen, very senior people fall on their swords because the estimates were wrong.
Why do you think these estimates are going wrong? Often when it's published in public spaces or you see how much a project's going to cost, it's usually a mega project that gets announced.
Hmm.
And for example, like here with high speed rail, or the Olympics in Tokyo or something, you see a headline figure for how much it costs, and then every so often there's major revisions to that number, or it's like the big flash headlines is the cost has gone up by X billion or something like that. And that just leads people to think, one, incompetency, two, that's too expensive, why aren't we spending that money on doing X, Y, and Z, like you said before. The perspective of someone who might be in project management or estimating world, or the professional world, might be like, well, why was the estimate so wrong? So that would be my question, is what is going wrong with the way we're estimating at the moment?
That's a really good question, and a lot of people have done a lot of research around that. But let me start by saying this: it's not only the mega projects. You can. I read an article about Grand Designs in the UK. Great program. I love Grand Designs, and 80% of the projects that are put on Grand Designs go over budget, and their overruns around £124,000. So I mean, it's not only, and I don't know. I challenge anybody who's ever refurbished a kitchen to tell me that it came in under budget. I certainly
Yeah,
don't. So,
yeah. Unless you do everything yourself.
that's it. Yeah, and even then, you're probably. But big projects, small projects, it happens a lot, and I think there's really three things that are critical on thinking about this, right? And the first is that we currently, I don't think want to be too negative about this. We currently, I think, do the best we can with the tools that we have had to date. The reason I say that is because many projects, and particularly those sort of larger ones or complex ones that you've mentioned, are really, really hard to do. And they have a lot of moving parts, and those moving parts interact with each other. Our methods of being able to manage those moving parts are limited by the amount of information we have, and the way that we can process that information. I think when I say, though, that we do the best we can with the tools that we have, I also think it's really, really important that as a professional approach, that we don't assume, which I think, we kind of do this from time to time, we don't assume that we have all the knowledge that describes the problem that we're trying to deal with. So by that I mean sometimes technology makes a very, very big difference to the way that we perceive a problem. My example around this is, if you had asked 100 doctors in 1800 what caused disease, pretty much all of them would have told you that the problem is miasma. bad air. And so that the way to avoid disease is to keep things clean, it's to have lots of air going through and so forth like that. But that theory was just completely wrong. It wasn't bad air at all. It was germs. Until germs were actually discovered, which was around about 1880 with Louis Pasteur and Robert Koch and those sorts of guys. When germs were discovered, people went, hang on a second, it's got nothing to do with the air. It's got to do with these little things we call germs. And so, science, the way it is, moves along. You have a theory. It's the best information and knowledge that you have at the time. And you approach the problem with the best skill that you have at the time. But the best skill that you have at the time isn't complete skill, and there's always something else. And I think that's a really important thing for us as people who are estimating cost to keep in mind that, this is not a static thing. It's constantly moving on. And that leads me to, I think, that the next main thing is that we need to, in many ways, look at our own rhetoric and face up to the evidence as it is. And we have a concept. An estimate is like a model. So it's like any other scientific model. And if I look at where project management and quantity surveying and those sorts of things emerged from, they really came from traditional practical trades and engineering and the like. And one of the reasons that buildings don't fall down is that engineers and scientists believe in the scientific process. The scientific process is you have a hypothesis and then you test what actually happens. And you compare that to your hypothesis. And if what actually happens doesn't fit your hypothesis, then you change the hypothesis. And I think, one of the issues that we've been really good at doing the best that we can, but with limited tools, we've said this hypothesis that if we estimate by adding up the sum of the parts and then applying a contingency to it, and that equals the whole, and then the whole doesn't turn out to be like that, then what we do is apply a bunch of excuses to it. Yes, but this didn't happen and that didn't happen and the other thing didn't happen. Our clients and our owners, they don't care about the excuses. What they want to know is, what is this thing going to cost? Not what is this thing going to cost if all of these criteria that could go wrong don't go wrong, because some of them will go wrong. It's important, I think, that we look at our own performance and we look at the evidence for that and saying, well, the evidence is that we get it wrong a lot of the time. It can't be reality that's wrong there. It's got to be the model.
Part of it for me is that day to day there's a lot of information management involved, probably not enough storytelling, but also there's very little, I think, in terms of reflection on what the estimator's, not necessarily skill is, but how they've performed and what is that measurement. We don't seem to have a standard measurement on the performance of an estimator.
That's a really important point. So to be fair to the estimators, let's say I estimate, a bridge. And I estimate, and I do my ground up estimate, and I've got steel and I've got concrete and I've got all those bits and pieces, and I get my subcontractor costs and add them to the process, whether I'm not sure whether I'm doing an elemental breakup or a trade breakup, but whichever, I come up with an estimate. And I'm a good estimator, let's say, and so where's my feedback loop? Because very often it's very, very difficult for the estimator to get actual feedback on what the actual outturn cost of that project was, because the outturn cost is enormously complex. It's attached to contractors making claims. It's attached to clients changing scope. It's attached to a whole bunch of unknowns about subsoil conditions and the like. So how does the estimator get that feedback, but to feed back into his skill set, or even the company that's doing the estimation? And, if you asked quantity surveying firms, how often do they compare the actual outturn cost with their estimated cost? You would find that very frequently that doesn't happen. So how do you test? How do you improve?
There's different attempts being made at things like standardizing cost breakdown structures or schedules of rates and things like that to carry out cross benchmarking, to do assurance of costs. And there's sometimes where you've got missing information at different parts of the chain. So you might have missing technical information on what the scope was for that particular estimate. So essentially what the basis of estimate was, when the actual first estimate was created, the reasons for the difference between that initial estimate versus contract price, or the reasons, costs attributed to change or compensation events, and then what that final account actually is. By the time you get there, the project might have gone on for a number of years. That the estimator might not be there unless something's gone seriously wrong on a major project. You won't get that level of investigation as to why that initial estimate was wrong.
Even if it has gone seriously wrong, you're unlikely to get it. What will eventually happen is there'll be a royal commission or something like that, or a government inquiry into what went wrong, and that will go on forever. And sometimes even the inquiries themselves go over budget.
And then the outcomes from that might be very high level. It might not be directly related to that project, but it might be, here's what lessons you can learn on projects going forward. It's not truly taken on board. It's done for the sake of it being done. I think that's pretty key. I think within estimating, you've got a way of working, and then we don't, like I said, we don't really test how good or bad our estimates are. I think just bringing it all the way back around machine learning, the application of machine learning to project and cost estimating, or schedule and cost estimating, how might it be effective in reducing the impact of those, I guess, mistakes with estimating?
I'm not sure that I would call it mistakes. I think I would call it limitations. I just go back to the statement that you made, how we try and link things that have happened and lessons learnt to our estimates. And I just put the reason that machine learning is such an important step in this process is that what we're really trying to do with projects is we're really trying to estimate something that is really, really complex. So everybody will tell you, and it's entirely true, that there are many, many things that can impact a project which change its outturn cost or its outturn time. And I'm not going to go into them because anybody listening to this, will have lived these many things that can go wrong. So it's a really complex and difficult thing we're trying to do. And that's where machine learning comes into the process, because machine learning has an ability to deal with three things that are very difficult for the current and traditional methods of estimating to cope with. And those three things are complexity, by which I mean dynamic relationships between multiple variables, some of which have feedback loops. That's a really difficult thing to deal with because in real time these things change and they have an effect against each other and against the overall estimate. And complexity is difficult, cannot really be dealt with in a simplistic and linear fashion. Without things like machine learning, or really advanced analytics that are able to move really fast, it's very difficult to keep up with the level of change, or to be sure that you're keeping up with the level of change. So that's one thing that machine learning is able to do that our current systems aren't really well suited to. Secondly, human factors. Whether we like it or whether we don't, there's plenty of evidence that shows us that humans have some limitations. There's lots of work that's been done around bias and bias adjustment. The UK Green Book for major projects references this and says that projects should be adjusted for bias. But the bias is, one of what I really regard as three issues that humans struggle with. One is bias, so that's like psychological factors. The second is that there are sociological factors, and you can dump politics into that group as well. And thirdly, humans are just neurologically limited, and that's obvious because even before we had computers, we had calculators, and before that we had abacuses. Why didn't we just do all that in our heads? Well, we didn't do it in our heads because we can't. Similarly, if you want to dig a hole, you can have 5,000 people with shovels, or you can have a 40-ton excavator and see how you go. There are human limitations. And thirdly, another really important feature of AI is that it continuously improves. And so I regard this problem as the problem of unknowns. We try to limit unknowns by having things like lessons learned and by breaking projects into ever smaller parts and doing really small bits of analysis. But the reality is that, with so many things that can go wrong and so many things that can affect the outcome, inevitably, in a practical sense, we're limited by the things that we can know at any one point in time. Let's say we have a problem with that we want to excavate a 5 meter deep hole, and in this material that has a pretty low CBR. And everybody in the room knows about digging holes, but nobody really understands the CBR, because the CBR guy He was away on leave on the day that we had this discussion. We decide, therefore, that we're going to dig up this hole and the sides of the trench are going to stand up, and then they don't. They just fall down. So the hole gets bigger and bigger and bigger, and our estimate of how much concrete we're going to put in it grows, and all sorts of terrible things happen. If that one guy who had known about CBR was in the room at the time, we wouldn't have had that problem. So we can't possibly know everything. One of the advantages of AI is that we can essentially externalize knowns outside of our heads, outside of our experience, and outside of the processes, the simple processes that we put in place.
There's obviously uncertainty, and then there's risk management that you need to separate out. Really, the sort of stuff that you covered there was a bit about knowledge and certainty. But then if you're using things in risk management, so we know that it's quite popular to use things like probabilistic tools and things like Monte Carlo and law of large numbers and all this kind of stuff, just to work out a bunch of different risks. If we take a situation where people are doing works during COVID and they started before COVID, you might not have taken into account the extreme event of COVID. The extremely at that point would have been considered extremely unlikely. Or in those situations, what would machine learning be able to take account of? Why would the decision maker then, let's say for example it was just before COVID, and the algorithm might have picked up some information that said this event would cause X amount of delay or reduce the amount of resource on site, and therefore extend the project out, or the project will cost more. What would the decision maker then, how would they then process that information and make a judgment almost based on the information produced?
First of all, machine learning is not a silver bullet. So it doesn't solve every problem. And if you've got a problem that emerges that the machine has never seen before, then it won't know about it. It won't be able to tell you that there's going to be an issue because it won't have ever seen that before. And that's exactly like humans. It's exactly like the situation that we currently find ourselves in. And that's the reason why we pay experienced professionals more than we pay graduates. Why do we do that? We do that because experienced professionals have spent 15, 20, 25 or 30 years, seeing things occur and making connections between those things, so that when they see an event arise that is connected to their earlier experience, they're able to reach back into their knowledge and go, well, I've seen this before, or I've seen this pattern before, and this tells me that I should be concerned about the impact of this, and which if you had a graduate, you wouldn't, that they would not have seen that. And so machine learning is the same. It can't know stuff that it's never seen before, because it learns. So that means you've got to teach it stuff in order for it to learn. Very often people see machine learning as it's a silver bullet to solve all the problems, and such a silver bullet can't possibly exist, so therefore machine learning cannot work effectively. But it's not that at all. What it is a process, a piece of technology that enables us to know more than we otherwise would, and to have more insight than we otherwise would, than by using our traditional system, human-based plus process-based systems. But that doesn't mean it knows everything. It's a probability machine. It's not really a cause and effect machine at heart. It's a probability machine. So, it's saying to you, well, when I see these particular set of conditions, because of the fact that you have fed me enough data that I can recognize this particular pattern and learn from the previous data, then I think that it's probable that, and here's the probability, it might be 80%, it might be 70%, that the future outcome of this will be X. But once again, if it says the probability that your cost will end at 22 million instead of 20 million is 80%, then what that really also means is that the probability that it won't be 22 million is 20%.
I think there is a tendency to think that this kind of technology will be that solution to absolutely everything. But even if it solves a single problem, where you would have machine learning, and this is where I guess you would need to be careful with what data you train it with, and the suitability of that data. But it solves a significant number of those problems that are due to the limitations of what a person is able to account for or physically do. given that also the time constraints that you usually have around estimating as well. So it's really another support tool
Yeah.
that can have a major impact on those areas that we just haven't been able to reduce in the past. And I'm just conscious of time because really driving on, and I'm not sure if you've topped up your wine
I'm
in the
topping it
past. But really, I think that what I wanted to get onto next was what is the Endeavour program.
Our objective is to be the catalyst for a change in the paradigm of the way we estimate time and cost on projects globally. We've been exceedingly lucky in terms of the fact that we just probably turned up at the right place in the right time. And, we regard cost overrun of projects as a social evil. The reason I say that is because let's take the Sydney Light Rail project, which many of our global listeners won't know about, but everybody in Australia knows about it. So this current project, as of June 2020, is $1.55 billion over budget. And that means that's $1.55 billion that the people of New South Wales now don't have that they previously expected to have. That's actually 3 regional hospitals. It's about 60 odd schools. So when you think about it like that, it's very important, I think, for societies that we get better at predicting and forecasting cost and time outcomes so that we can make appropriate decisions about whether we do a project or not, or we don't do a project, and allocate our community resources to the places where the community regards is the best bang for the buck. So, I think we're in a position here where we can do something about that. We found ourselves, Kong and I, at Oxford University at pretty much the same time as Professor Flubier and his friends there had spent over a decade researching project outturn costs and the effects that they have. And we've been able to build a machine that essentially operationalizes some of those theories. What we want to do now is just spread that around the world so that more people can use it. I know there are other companies around the world. I know who they are. They know who we are. There's about 6 of them that are working on this at the moment. And, I say good luck to every single one of them, because the problem in this respect isn't about competition. It's about the ability of AI, however it's applied, to change the outcome of projects or to predict the outcome of projects so that the community can get good results.
I guess, is there a specific application of projects, or is it a particular stage of a project that you can actually start to do this, or do you see this as something that can be a support tool throughout the life cycle of the project? Because there are studies that show that the decisions you make early on in the project life cycle, they have the biggest impact on cost and the ability to drive change in a project.
That's true. And what you really want is to get that early stage estimate right. But then let's face it, lots of stuff happens throughout a project. And some of those things that happen because projects are complex can have a big downstream effect at any point in time. So our focus is to be able to iteratively forecast based on real-time information so that, decision makers in projects can get the best knowledge that they can get, both from their AI output and from their expert estimators. Because in the end, artificial intelligence really isn't a thing by itself. It's a socio-technical tool. So it's really a matter of having the people who are expert estimators and those who are forecasting during the project simply see AI as another tool that's on their tool belt. Another information that they couldn't otherwise get themselves in the time and cost constraints that they have to be able to provide advice to make sensible decisions. And that's got to happen consistently through the project. So that's the process that's the way we built our AI forecaster.
It's a great place to probably leave our discussion for today. There's so much more I do want to ask, but I think just to wrap up, firstly, where can listeners find out a bit more about the Endeavour program, about AI and cost estimating?
If you look at our website, we're launching a new website very shortly, so that'll be exciting. And also, if you look at some of my LinkedIn posts or the LinkedIn posts from Endeavour program, you'll see those. But I also urge people to look at the work of Ben Fluvier at Oxford. It's really his theories that have formed the foundation of our AI machine and have been responsible for much of its success to date. I guess I encourage people to debate this issue because there are no simple answers to it. Learn about AI, learn about machine learning, and then let's have some healthy debates.
Yeah, I'll certainly link to those in the description. Just to wrap up then, so what is your one takeaway message for the listeners?
Regardless of how good AI is, AI doesn't do things. It just tells people things that they otherwise wouldn't know. So people do things. People make decisions. AI is not good at everything. So you've got to use it for what it's good at. And that requires a bit of investigation and a bit of experimentation, particularly around the fact that in our industry of cost and time estimating and major projects, we're at the very, very early stages of this, and there are many other industries that are way more advanced. So, look at other industries and see what they are doing, and maybe interpret that to see how we could use it.
So AI in project scheduling and estimating is here. You need to be prepared for it as an estimator. I still have loads of questions. AI should take out the conscious biases in estimates where they exist. But training the AI with certain information, selected or not selected, I think introduces a new sort of bias. Let me know what you think on the LinkedIn page. On the next show, I will reveal a big collaboration coming up. Until then, have a great week.